Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosine River College in Sacramento, California. This video is kind of a summary video for graphing sine and cosine functions. This is putting everything together, making sure that you know how to graph every little piece of the sine and cosine function. If you have not watched them, you should watch my videos on deriving the base graph for sine and cosine, amplitude, reflections, midline, and vertical shifts. And in my last two videos, period, key points, and step sizes, and then the last video being phase shifts. All of that critical for this conversation. So let's go ahead and talk about how to graph in general. There's no way you need to actually go step by step like this, but this is honestly what you end up doing when you graph a sine or cosine function. Very first thing you do is just say, is it a sine or cosine? You determine the base graph. You also want to determine if it's vertically reflected. That is its coefficient negative, right? If this coefficient here is negative, then obviously the graph is flipped about the x-axis. Then you want to state the amplitude, because that's going to be very helpful. You're going to state the period, you can state the step size, the phase shift, the vertical shift in midline, which is y equals d. You're going to then go into graphing. So at this point right here, you start graphing. You didn't graph up until that point. It was just all a bunch of algebra, but now you start graphing from this point forward. All the rest is just information. So you graph all this information. You graph the midline, graph your base function. It's reflected again if your coefficient is negative. You then label the initial point at the phase shift and the key points using the step size, which was the last video we did. You draw the y-axis in the appropriate location. You label the y values for the midline and the maximums and minimums. And you use your amplitude to help with that. We'll see that in an example. You draw the x-axis in the appropriate location. And then, if you're asked, you extend the graph a little bit. All right, let's see how this works. I should mention, I'm not going to go through a 12-step program here. I'm just going to kind of go through and do what I need to do. So I note that it's a negative sine function. That's the first thing I note. I know it's a negative sine function. Let's state the amplitude. The amplitude here is the absolute value of that coefficient of sine, which is -2. So that amplitude is going to be 2. And it's properly labeled amplitude because it is actually how loud that sine curve is. And I'll do a video on that later on because it's really neat that you can actually listen to sine curves. All right, so that's the amplitude. And then we're going to talk about the period. All this information is incredibly important for graphing. Period is 2 pi over b. Remember, b here is the coefficient on x. So that's 2 pi over 3. And then the step size is the period divided by 4. So period over 4, which is going to be 2 pi divided by 3 over 4, or 2 pi over 12, or pi over 6. You want to reduce that down as much as possible. And then let's see, phase shift. The phase shift is going to be, let's see, 2 ways you could do this. In the last video, we did it this way, -2 sine of, and then we factored that 3 off of both of these terms. So 3 times the quantity x plus pi over 3. And we said, oh, look, what turns this argument into 0 is -pi over 3. So therefore, the phase shift is a -pi over 3. The other way you could do it is to recall that that is what we call C, and that's the same thing as -c over b. 2 ways to do it, your choice, I don't really care. And let's see, that's our initial point, midline and graph. Okay, midline, which is also known as a vertical shift. Vertical shift. From this point forward, I will not write that. I will just say VS for vertical shift. And that is the D part. Has it been lifted or lowered? It has been lowered 1 unit. Now, to graph. To graph, I start with the vertical shift. I graph the midline. So I'm going to go ahead and I use green to graph that midline. And I usually dash it if I can. Although when I do this on my computer, sometimes it moves the screen. So I beg your forgiveness if it does that like it just did. And I'll just continue forward like this a little bit. Okay, so I've graphed the midline. I'll label the midline. That's y equals a -1. Now that I've graphed and labeled the midline, let me just get that out of the way. I want to start graphing my trig function. It's an upside down sine curve. That's critical to note. It's an upside down sine curve. So I'll just graph a sine curve, but upside down. I'll try to be as accurate as possible. Actually, I should do it this way. Boom. Let's do it like this. I think that's about right. So this is the upside down sine curve. Hopefully it's spaced appropriately. That looks about right to me. That's actually pretty beautiful. All right, so that's the upside down sine curve. Now I'm going to label my key points. We start with our phase shift. The phase shift is where our initial point has moved. So that is going to be a -π/3. However, I mentioned it in the last video that you want your phase shift and your step size to have the same denominator. So I'm going to write this as a -2π/6, just because that way these two denominators are the same. They're much easier to work with like that. So I know my initial point is going to start at -2π/6. To get to the next key point, I will add the step, a π/6. So adding a π/6, I'm now at -π/6. Add another π/6, I'm at 0. Add another π/6, I'm at π/6. Add another π/6, and I'm at 2π/6. Notice again, statement from last video, but notice again that it didn't end at the period at 2π/3. It ended at 2π/6. However, the total distance, if you were to compute it here, is actually a 2π/3. That distance is 2π/3. So please do not get into the bad habit of labeling your ending point as the period. That's a terribly bad habit. You should always use the step size. You have been warned. Now that we've gotten that far, I'm going to go ahead and draw in my y-axis. Just drawing that in just like that. Didn't mean to use blue, but there it is. So there's my y-axis. I'll label my y-axis here. Let's see. You can see off to the right-hand side, the midline is at a height of a -1. So I'll just draw this. I'll say that's a height of -1. I'll erase that 0. It's unimportant. And then to get to the maximums and minimums, I will wiggle up and down by the amplitude. The amplitude in this case is 2. So I know that the y values are going to increase by 2 and decrease by 2 to get to those maximum and minimums. That's what the amplitude says. So -1 plus 2 is 1. -1 minus 2 is a -3. And this tells me where the x-axis is. It's halfway between that -1 and +1. I'll just draw that in right here. And that's my x-axis. Have I labeled everything? Yes, I have. Everything is done on this curve. Now, if your instructor wants this extended out, you could just do something like this. Or if they say graph this between these two values, whatever the values are. I think that's kind of a cruel question, but if they did, you can extend this out to those values. All right, so that is a full graph. That's what you can expect on a trig exam for graphing sines and cosines. Very, very common style question. Notice I always start with the mechanics. I don't actually graph anything until I have all this information down. So I essentially pull everything from the function they handed to me. And then I start graphing. And when I start graphing, I actually graph I graph basically by climbing this ladder. I first graph the vertical shift, then my phase shift I plot, then I start counting by step size. I kind of skip the period because that doesn't really matter. We used that already. And then I label the y-axis using the amplitude. So I guess I go back up that ladder. Now, obviously, one example will not do it. You want to go through several examples here. So let's go ahead and go through several examples. Note, on an exam or something like that, your professor might not tell you what to state. They just might say, give me all information for this graph and graph it. So be very aware. Follow all my steps here so you get in the habit of doing this. So I know I need to state each of these key pieces. This piece, all these play a role. So let's go ahead and go through one by one. The amplitude is associated with that 3. It's actually the absolute value of that 3. This 3, by the way. So it's 3. Then I continue to go to the right. That 1/2 has something to do with the period. Specifically, 2 pi over it will be the period. So 2 pi over that 1/2. So the period here is 4 pi. So I've taken care of that, and I've almost taken care of that 1/2. That period will allow us to compute a step size to allow us to graph appropriately. Step size is just the period over 4, which is 4 pi over 4, which is pi. It's actually a nice step size. Nothing wrong with that. We're almost done with that B, but it actually gets used one more time for the phase shift. The phase shift is negative C over B. So it's a negative pi over 4 over 1/2. And so this looks real messy to people, but luckily you should have reviewed simplifying compound rational expressions. So this is why you have to review that material, because it's critical. So negative times negative is positive. Multiply top and bottom by 4, and you'll get pi over 2. Pi over 2. You can do the arithmetic. I'm telling you, that's the answer. So pi over 2 is our phase shift. So now that we're done with this and this, now I just move on to the last one, which is our vertical shift, and that is equal to a positive 3. We are totally done with the mechanics part of it. Now we go into the graphing piece. So I'm going to graph my midline. My midline is from this guy right here. So I'll just graph that in green, dash, 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 dash. Once I get that done, I'm just going to label it. It's a height of 3. Let me get this ruler away. And let's see. Now I'll go ahead and graph my function. My function is the cosine. So I'll go ahead, and it's not a negative cosine. It's a standard cosine. So I'll just quickly sketch out a standard cosine. Plot. I'll try to evenly space these if I can. All right, there we go. That's actually a pretty good cosine as well. All right, so there's my cosine graph. Not the entire graph, obviously, just some one period of it. And then we label the phase shift where we're starting to graph. So that happens at x equals pi over 2. Remember that I like to get my phase shift and my step size to be the same denominator. So step size I'm going to write as 2 pi over 2. Okay, so phase shift is at pi over 2. And then from there, I'll go to the next spot. I'll add 2 pi over 2. So I'm at 3 pi over 2. I'll add another 2 pi over 2. 5 pi over 2. Add another 2 pi over 2. 7 pi over 2. And finally, one more 2 pi over 2 to get to 9 pi over 2. That distance between 9 pi over 2 and 1 pi over 2 is actually 8 pi over 2, which is 4 pi, which is actually our period. So we use step size. In the process, you use the period. And finally, we're going to use the amplitude. Now, the amplitude is used to state where the highs are and where the lows are on this. So if that is where pi over 2 is right here on the x-axis, technically that's not the x-axis, but whatever, then 0 is probably right about where I've placed, let's see, this would be pi. So yeah, probably 0 is probably right about here. So I'm going to go ahead and graph my y-axis. Here's my y-axis right there. And I'll go ahead, I'll maybe move this off to the right here. Label that y. You graph that y-axis, you want to label the maximums and minimums. You also should label the midline 3. And the amplitude will just tell us how high to add, how much to add and how much to subtract from that midline. So our amplitude is 3, so we're going to add 3 to get up to here and subtract 3 to get down to here. And that will tell us where we need to plot our x-axis. It's at a height of 0. So plotting in the x-axis, you can see that's our x-axis right there. And you have a full graph labeled appropriately for the cosine curve. And of course, again, it continues on in both directions. So you can see it's very methodical. It's a really beautiful way to graph sine and cosine. As the last example in this video, we're going to go ahead and do something that I often give my students because I want to see if they're actually awake and paying attention. And that they're not afraid of decimals. This problem will not be pretty, but mathematically, or at least graphically, there's no difference between this problem and the previous two. It just looks terrible, but it actually isn't. Let's go ahead and start by going through from left to right. Oh, I should mention, by the way, some authors love to write these functions like this. Negative 1.7 plus 0.3 sine of 2x plus 5. Okay, if they write it that way, I would rewrite it this way. I'd like my sine function to be listed first. It's just a better way to write it. So I think authors do that to really throw you off. But my advice is always write it where your trig function's first and your constant is the last term listed. All right, so what is the amplitude of our function? Well, remember, amplitude is the coefficient of the sine. So our amplitude is, well, it's absolute value of that. So that's going to be 0.3. Now that we're done with that, we move on to the period. And the reason why I know we're moving on to the period is because that's the next number in line. It has to do with the period. So period is 2 pi over that number. Oh, period's actually kind of nice here. And the step size is going to be that period over 4. So that's pi over 4. Nothing bad yet. I say yet because I know something's coming. Now let's go ahead and move on to this guy. And that has something to do with the phase shift. The phase shift is equal to negative c over b. That's a negative 5 over 2. And here's where we have an issue. Because remember, when you start graphing, you start at the phase shift and you add your step size. Well, the step size has pi's in it and our phase shift does not. But don't worry, there's a nice way to write it, so don't freak out. And finally, the vertical shift. How do I know I'm doing that next? Because that's the last one in line. And the vertical shift is negative 1.7. Let's go ahead and graph. Let me find my ruler. There it is. So I'll graph the midline. I'll actually graph it down here since it is at a negative 1.7. I'll just make it solid because, well, I want to. Let's see. It's a regular... Oh, let me label it too. Y equals a negative 1.7. I'll just label it for right now. I'm going to erase it in a little bit. In fact, you know what I'm going to do? Well, no. I'll keep it like that. Fine, whatever. The sine curve is what we're graphing, so let me just graph a base sine curve, a basic little sine curve here. I'll do it in blue. I'll start here. Well, it could be better, but that's good. All right, let's go ahead and now start at the start at the vertical shift. We already did that, so that's done. I'll just check that off. Check. Now we're going to label the phase shift. That's our initial point, -5/2. I'm going to label this -5/2. Now remember, I go by steps to get to these key points. So let's see what the step size is. A pi/4. So we're going to step by a size of pi/4 from here to here. How are you going to do that? -5/2 plus pi/4. That's how you're going to do it. That is perfect. Then, to get to the next point, you're going to step again by a pi/4. So you're at -5/2 plus 2 of those pi/4s. Yep, just that easy. Step by another pi/4. So you're at a -5/2 plus 3 of those pi/4s. Step by another size of pi/4, and now you're at -5/2 plus 4 pi/4. And that's it. That's how you label your key points if you have weird numbers that can't add nicely. So we've done that and that. Technically, the period is already taken care of as well. Now, probably the hardest part of this is figuring out where the y-axis is going to go. Because again, that's where I need to plot the amplitude on. So the y-axis requires us to really know the size of these numbers. A -5/2 is a -2.5. Well, now I have to kind of really figure out, well, which of these numbers becomes positive? Where does 0 occur? Honestly, you could probably grab a calculator for that part. And if you can't, then your instructor might set up a problem where it's a little more obvious. However, 0's halfway or partway between -5/2 plus 3 pi/4 and -5/2 plus 4 pi/4. It likely is, like on an exam, you wouldn't know that. So again, your instructor might set you up with a problem that avoids that if they don't allow calculators. All right, so this is the y-axis. And now I'm going to label the y-axis appropriately. Let me scoot that off to the side. See, our midline was at -1.7. So this height here is a -1.7. And our amplitude was a 0.3. So that means that we'll wiggle up by a 0.3 and down. Down didn't work well for me. And down by a 0.3 to get to the maximums and minimums. So up by a 0.3, add a 0.3 to -1.7, and you're at a -1.4. Subtract a 0.3, and you're at a -2. Those are my highs and lows, and that just allows me to figure out where the x-axis is. Now, that x-axis is probably going to be way up here. So a better way to note that is maybe I'll just do this. I'll erase this, and instead I'll do something like this. If you know your x-axis is far up above, you can do a little trick like this. This allows your reader to know that you're kind of squishing your axis a little bit because you want to cover a lot of distance in a short period of time. Oops, I kind of missed on that one, but that's okay. And so I'll put my x-axis right here. It's relatively speaking not supposed to be right there, so I kind of squished the axis a little bit. But that's my x-axis. All right, and let me turn off my ruler so you can really see this all its glory. If you want to get rid of the midline, you totally can. That allows me to get rid of that silly dot that's been sitting there the entire time and label my -1.7 appropriately. So I'll just put it right here, -1.7. But otherwise, everything is perfectly fine there. That is my graph. And if you want to graph to showcase it continues on forever, you can just do little dashed lines like this. That tells the world it continues forever in that pattern. There you go. That is a full-blown graph of probably one of the harder graphs you'll ever do for sines and cosines. And if you can do that by hand, you can make up any numbers you want. Just practice all day long. Make up anything. Look at any trig function you want online as far as sines and cosines. You should be able to graph it now. There you go.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes complex, more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close, don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.